If you are interested in addressing the huge problems that the world is going to be facing in the next generation, issues of air quality, petroleum reliance, urban planning for a world population of 7 billion people.
We are just about at the next inflection point in the industry. We're going to put more change into these vehicles in the next few years than we've seen since, as far as I'm concerned, the beginning of the industry. We're putting in electronic controls, infotainment systems that are going to change the way people interact with the vehicle in a fundamental fashion.
The Chevrolet Volt itself, we have the number of controllers exceeds anything we've put into production to date. So the role of the computer engineer, the electrical engineer has increased dramatically.
If you think about everything that we have on our cars today, our cars are more complex than the space shuttles that we were sending off.
Each vehicle has at least 40 up to 60 modules, control modules. Each of those modules has at least one microprocessor in it with software, complex algorithms and drivers and test tools and development and validation behind it.
EcoCAR 2 is a 3-year automotive engineering competition that challenges 15 North American universities to reduce the environmental impact of a 2013 Chevrolet Malibu without sacrificing the consumer acceptability of the vehicle.
This competition takes students from those tracks, whether they be electrical, computer science, mechanical, and it exposes them to a real-world systems engineering challenge. And if you ask my peers in industry, they will tell you that is the type of engineer they're looking for.
Freescale is probably most well known as a processor company. You'll see us in processors for things like cell phones. We're actually big in the e-reader market, in tablets. Automotive really has some unique requirements, and that can be hard to learn in a university classroom environment. But boy, the students who really get something to work, on a real car, they get it to work reliably, they get it to work on a deadline. Those students really have the kind of experience that the automotive industry and the electronics industry is looking for.
We get access to hardware and software that is worth millions of dollars. We have the opportunity to learn how to use it before we even go on the job. So then once we're on the job, we can say, oh yeah, I've worked with MATLAB, I've programmed a controller 10 million times.
We are providing each team with a full reference design to do a reconfigurable center stack. All the hardware and software that they need, a state-of-the-art hardware platform, a quad-core processor, the i.MX6 quad, running a QNX operating system, which is what is really being developed in leading-edge applications today. Certainly the graphical user interface is a key. There's a lot of ability to develop different types of graphics, 2D and 3D graphics, experience in using some of the new embedded standards in graphics, OpenBG, OpenGLES, that again are really in demand in the industry today. Really our main goal is to provide the teams just a big sandbox that they can do whatever they want. Navigation apps, voice recognition, communications to infrastructure, have remote units for passengers. We're really trying to unleash the creativity of the EcoCAR 2 teams.
A123 is a platinum sponsor, and they are donating the lithium-ion modules. The battery system itself has about 20 kilowatts of power. In order to take advantage of that high power capability, you need controls. You need electronics to be able to control that and to integrate that into the systems. So we have a strong need and desire for electrical and computer engineers.
This isn't about just connecting wires together, it's also about getting all of your systems integrated together and communicating and talking to each other properly. Your average electrical engineering student is going to have plenty of application related to his classwork. That's mainly to do with DC and AC circuit theory, electromagnetic generation and mitigation, and resonance and harmonic analysis of your electrical systems.
Based on the students' activity on the EcoCAR program and the hardware-in-the-loop design that they're doing, they're going to determine what the power requirements are going to be for their system. For the energy storage system or ESS design, there's a lot of control theory and circuit theory that goes into that. There's the mechanical packaging, there's the mechanical cooling design, then there's the communication aspect, communicate with the vehicle through the CAN network. A lot of software programming.
I've learned so much through this project that I can't even list it anymore. Hybrid vehicle design, electronics design, high voltage safety, high voltage integration, engine calibration is something I'll be learning about in the future, control systems. The opportunities in this project are endless.
For EcoCAR, the HIL is their development platform. The simulator gives them the ability to go from the initial idea all the way to the final implementation of that. This is the type of curriculum that is needed to train the engineers that we need in industry, actually. We need computer science students who know how to model, who know how to implement control systems, right? Conversely with mechanical and electricals.
The vast majority of EcoCAR students don't have to worry about finding a job because all the sponsors that are involved in the competitions, they interview with the students. That's where they find their next generation of engineers, is through the EcoCAR program. I'm actually a product of the EcoCAR 1 competition, and I was an electrical engineering graduate student.
Really, the industry as a whole is almost struggling finding resources in these key areas. And everything in our vehicles are really gearing towards more and more electronics. And having that deep technical background and what the education can provide for you is really key for us as we look to what our future workforce is going to look like.
It's really time that faculty and university students together understand the need for collaboration, the collaboration that's required to respond to the difficult problems that the industries face in engineering. So ECE students need to feel very comfortable collaborating with their fellow ME colleagues and vice versa.
The college environment, programs like EcoCAR couldn't be any more important because that's really a great opportunity, I think, for students to be able to see what happens in the real world. That no one engineer operates completely within their area of training, that you really have to interact with people of many disciplines to be able to bring a complex product like a vehicle to the marketplace.
As a company, we are involved in education globally, and I have to say that EcoCAR by far represents that best opportunity.
The students that we hire from the universities are all uniformly smart. That's a condition of entry into engineering school. What we need the universities to focus on is cross-departmental coordination and skills. I need someone who has mechanical, electrical, and computer science skills all in one engineer. The EcoCAR Challenge is a great opportunity for these students to get those exact skills that we need. The students that I hire from this program, I can drop them into our most ambiguous, unstructured problem. They hit the ground running and they get results.